So we're going to cover some of the high points of Chapter 11 in this lecture. Chapter 11 covers correlation coefficients. And we use correlation coefficients for measuring the association between two different variables. So the term correlation is used in a lot of language. You probably have heard things are correlated, or you've maybe read that or heard people say that. And so it indicates some type of association or relationship between two different things. In statistics, correlation concerns a specific type of relationship that's measured mathematically. So a correlation coefficient provides a measure of the strength and the direction of an association between two different variables. And a p-value is calculated to provide an assessment of whether that association is statistically significant or not. There are two types of correlation coefficients that you'll see used, and they both measure association. So there is the Pearson and the Spearman. So the Pearson correlation coefficient is used when both of the variables are normally distributed, a parametric test, as you've seen with some of our other types of tests. And the association of two variables are in the interval or ratio scale. The Spearman correlation is used when the data in either one or both of the variables is not normally distributed, so our non-parametric test, and that the measures of the two variables are ordinal, interval, or ratio. So depending on what type of data you have, depends on what type of correlation you would need to run. So we again start with a null and alternate hypothesis. And so a null hypothesis might look something like there is no correlation between the two variables, and our alternative hypothesis is that there is a correlation between the two variables. And correlation is measured by a lowercase r, so you'll see that reported in a correlation that is a lowercase r with a number. So basically, if there's no correlation, r would equal 0, and if there is a correlation, r would not equal 0. So we measure, as we talked about before, measuring strength and direction. So we'll talk about these two things. So correlation coefficients are denoted by a lowercase r. The r can fall between -1 and +1. And so any number between -1 and +1. An r equaling -1 means there's a perfect negative or inverse relationship between the two variables. So basically, as one variable increases, the other variable decreases. An r of a +1, so a +1, means that there's a perfect positive relationship, and that means as one variable increases, the other variable also increases. R0 means there's no relationship between the two variables, and basically an increase in one variable is not associated, or there isn't a predictable change with another variable. And the closer correlation coefficient is to 0, the weaker the association is between the two variables. So if you're closer to 1 or -1, that is a stronger correlation. If you're closer to 0, that's a weaker correlation, whether it's positive or negative. So the square of the correlation coefficient, which is indicated by r squared, lets us know how much of the variation is shared by the two variables. And so, like, if you think about a Venn diagram, the shaded area would be this r squared. And so we see how much of variable A and variable B, how much of that variation is shared by the two variables. So here's an example of a graph of a data set, and I have this a little bit blurry, sorry about that, for no correlation. So there's no correlation between this data. The R would equal 0. You can see that all of these blue dots are data points in our data set. A perfect positive correlation, all of these data points would fall along a line that is positively correlated. So that would be a graph of an r equals 1. And then here, a negative correlation is just the opposite. So you're heading in a downward direction, but you can see that it is a perfect line. All the data points line up along that line for a perfect negative correlation. You don't get perfect positive or negative correlations very often. So you're not striving for perfect, but that just gives you an idea of what a perfect one would look like. So the types of research questions that correlate, with doing a type of correlation. So what would you use this for? So an example might be that you're interested in predicting who will do well in statistics. So we give everyone a screening test at the start of the class, and we score that screening test from 0 to 100. And then we get everyone's final numerical grade, and that grade is scored from 0 to 10. So we're going to see if there's any correlation between the screening test and the final grade in the course. So how could we tell if the screening test was any good? So our research question would be, is the screening test positively associated with the final statistics grade? That is, do people who do well on the screening test also do well in the class? Our dependent variable is the final statistics grade, and our independent variable is the screening test. And these are both ratio variables. So types of data and our assumptions, remember, we always have assumptions that have to be met in order to run a particular test. So for the Pearson, that the two variables are either interval or ratio. The two variables are normally distributed. They are related to each other in a linear fashion, and there are no outliers. So no variables that fall outside the pattern of the rest of the data. In the Spearman, both of the variables are either ordinal, interval, or ratio. The variables don't have to be normally distributed. The two variables are related to each other in a monotonic, in a monotonic way, but it doesn't necessarily have to be linear. So the direction of the relationship doesn't change, but it doesn't necessarily have to be a linear relationship. And the Spearman test is less influenced by outliers. So if you have some outliers, the Spearman might be the more appropriate test. So our 6 steps in correlations, you're going to state the hypothesis, define the significance level, make sure the data meet all the necessary assumptions. Look at the scatter plot of the two variables, obtain the correlation coefficient, and determine the statistical significance and state a conclusion. And so I'll be walking you through how to actually run this in SPSS in a different lecture. But here we'll walk through sort of the 6 steps. So is the screening test positively associated with the final statistics grade? So to answer the question, we will use the data from 10 graduate students. Each of them took the screening test and before they started the class, and then have a class grade. So the dependent variable is our statistics grade, that's our outcome, and then the independent variable is a screening test, and those are both ratio variables. Next, we state the hypotheses. So the null hypothesis being they are not correlated, and the alternative that they are. You're going to define the significance level. We're going to choose an alpha level of 0.05. The degrees of freedom, you'll calculate sort of the degrees of freedom. So we have your n degrees of freedom are n minus 2 because we have two different levels. And so we have 10 students. So our degrees of freedom is 8. The critical value, if you were calculating this by hand, you would look up the critical value, and we would see that our R is greater than the critical value, and you'll reject the null at alpha 0.05. Remember, you don't have to calculate these by hand. We're going to calculate these in SPSS. You're going to check that the data meet all the assumptions that we've talked about. You're going to create a scatter plot. So from the scatter plot, you can see that there is a positive, although not perfect correlation. So you can see that these data points, you can see they move in a positive direction, but it's not perfectly linear, right? They're not on that perfect line, but you can see that they fall within sort of a positive relationship. So when we calculate the Pearson correlation, we can see that the correlation coefficient is 0.05. 0.617. So that's a probably moderate correlation. And our significance um, is 0.057. So that's significant. It is not significant. And then our R squared value is just this number squared. I'll walk you through sort of the interpretation also in a separate lecture. So the correlation between the screening test and the final statistics grade is 0.617. R squared equals 0.38. However, the p-value is greater than 0.05, so this correlation is not statistically significant. There are other types of correlation, and so you may come across some of these: the phi correlation, point biserial, Kendall's tau, contingency coefficient, or universal measures. We don't go into a lot of these, and I don't make you calculate a lot of these in this course, but you should be aware that there are other ways to calculate correlation depending on the type of data that you have. There's partial correlations, where you can describe the relationship between two variables, controlling for a third variable. There's semi-partial and multiple correlations. And so there's lots of different ways that you can do correlations. We're just going to do some of the basic calculations for this course. So in summary, a correlation is a procedure for quantifying the relationship between two or more variables. Correlations measure the strength and the direction of the relationship. And the Pearson correlation is looking at linear relationships between two normally distributed variables on an interval or ratio scale. And our Spearman correlation can be used when the relationship is not linear and when one or both of the variables is not normally distributed or is ordinal.